Hello, dear students. I am here, LP BHAIYA, Associate Professor, Electronics and Telecommunication Engineering Department. Dear students, we have already studied about the multi-stage amplifier, and you are well known what are the advantages of the multi-stage amplifier. Similarly, today we will go for the practical aspect of one of the type of multi-stage amplifier. In your syllabus, we have a lab also for RC coupled amplifier, and today we will discuss about this RC coupled amplifier and its frequency response. Let us see, I am going to talk about RC coupled amplifier. RC coupled amplifier. Actually, we have already seen this RC coupled amplifier also. But as far as the practical concept is concerned, I am now going to discuss this RC coupled amplifier. This RC coupled amplifier used in the low frequency circuits, where low frequencies applications are used from, let us say, 0 Hz to about 100 kHz. And the practical purpose, this RC coupled amplifier is used to get the flat response within a particular bandwidth. So that we have to find in practical also the response of the RC coupled amplifier. So what is the aim? What is the experiment which is given by the university in this particular subject on this particular topic is, you can write here, the aim of the experiment is to plot frequency response, of RC coupled of two-stage RC coupled amplifier. RC coupled amplifier. This may be the title or aim of the practical, and this is one of the practical of your analog electronics also, to plot the frequency response of a two-stage RC coupled amplifier. Then what we have to do? You just go through the circuit diagram first. So let us see this circuit diagram of two-stage RC coupled amplifier. One step by step we will go through this particular practical, and this is in theory also. So you are already known about the theory. I am going to explain about this frequency response. So circuit diagram is something that I am going to draw here the practical circuit diagram which can be used in the practical purpose. So we will put the values of the components here also. This is transistor 1 and this is the collector resistance of transistor 1. Let us say RC1. I will give the value of these components later on. I have got these values also practically, where I will draw first the circuit diagram, then I will put the values. This is collector resistance 1 here. This is RC coupled, so this coupling capacitor is there, and the next stage transistor is here. Now you can have this emitter resistance. This emitter resistance is the RE1 and this emitter resistance is RE2. Since we want to go for the frequency response, we will put the bypass capacitor to both these emitters. So here this bypass capacitor is used. Similarly here the bypass capacitor can be connected. Here collector 2, resistance at collector 2 is used, that is RC2. And in between we can use the voltage divider bias, this one and this one. This is the voltage divider bias. I will put here R1 and R2 of the second stage. Similarly, voltage divider bias at the first stage. This is the voltage divider bias at the first stage, R1 and R2. So here you may use for practical R1 and R2, all components are same. These two R1 are same, these two R2 same. Or for the gain adjustment purpose, you can use the different values. The practical circuit which I am using, having the different values, I will give you later. First, you connect this to the plus 5 volt supply, 5 volt DC supply to this transistor and to transistor for this biasing. And then use the coupling capacitor over here and use the output, take the output across this load resistance R1. This transistor T1 and this transistor T2, and this is the common ground. This is the common ground, and take the output here V0. So this is the two-stage RC coupled amplifier. You can connect the source resistance here and input V in. V in here. This may be a sinusoidal, and this source resistance you can use here. So this is first stage of the RC coupled amplifier. This is second stage of RC coupled amplifier, and 5 volt supply may be given. So this is the circuit diagram for the two-stage RC coupled amplifier. Now let us see the practical values of this RC coupled amplifier. I will write here. This capacitor is of 0.1 microfarad here, and this capacitor is 0.1 microfarad. This coupling capacitor is, you can use the capacitor here also, maybe it may be used at the output side or may not be used. You can use either load here or you may not use the load. You can see both the practicals. Here RC2 is of 4 kilo ohm and RC1 is of 15 kilo ohm. This value is 15 kilo ohm. Then R1, this is 200 kilo ohm, 200k, and this R2 is 20 kilo ohm, 20 kilo ohm. Similarly, this R1 is 47 kilo ohm and this R2 is 4.7 k ohm, 4.7 kilo ohm. So this is the circuit diagram along with the values. I have written here values. 15 kilo ohm RC1, RC2 is 4 kilo ohm, R1 is 47 kilo ohm, here R2 is 4.7 kilo ohm, but these R1 and R2 are different. This is 200 kilo ohm, this is 20 kilo ohm. This RS, the value of RS is equal to 1 kilo ohm here, 1 kilo ohm, and sinusoidal input may be considered here. RE1 is 100 ohm and RE2 is 330 ohm. And if required, the H parameters of this standard, both transistors are equivalent transistors, so you can consider these H parameters if required. These values are HIE is equal to 1.2 kilo ohm, 1.2 kilo ohm, HFE is equal to 50, then HRE is equal to 2.5 into 10 raised to minus 4. Then HOE is equal to 25 into 10 raised to minus 6 ampere per volt. So if required at any stage, we can use these parameters, H parameters for common emitter amplifier. Since both transistors are equivalent, both transistors are similar, we can use same parameters for the both transistors if required. But in practical purpose, we don't need these values. We have to calculate the frequency response, and therefore we does not require these values. But at any stage, if for the analysis, if we require, we can use. Otherwise, no need of these values. So this is the circuit diagram. Then what we have to do in case of the practical purpose, we have to calculate the magnitude of the gain. That magnitude of the gain is nothing but magnitude of output upon magnitude of input. And this input is fixed. The amplitude is fixed, let us say 0.5 volt peak to peak. we will keep this input V in. We will keep this input V in. Its amplitude is 0.5 volt peak to peak is fixed. And now we will vary the frequency, input frequency, this F. So F should be varied continuously. So what we will do? We will use the function generator here. And from the function generator we will take the sine wave, and the amplitude of the sine wave will be fixed at 0.5 volts. That is peak to peak value. This means this is the sine wave and this peak to peak value is considered as 0.5 volt. So we will take this 0.5 volt and we will vary this frequency. So input frequency should be varied from the function generator at this side, and measure the output voltage on the second channel of the CRO. So we will connect the CRO here, second channel of the CRO, and first channel is connected to the input. And first channel at the input we will apply the from the function generator. So at the input side function generator, at the output side CRO, and accordingly note the output voltage for every stage of the frequency, and then calculate output upon input. Input is fixed, output will be varying at different frequencies. So calculate this gain, you will get the gain, and calculate the amplitude gain. So what we will do? We will prepare the table for this calculation, and from the table we will draw the characteristics, and these characteristics will give you the frequency response. So what, how we can draw the table or plot here the particular characteristics? Put the serial number in the first column, then we will keep this V in is equal to 0.5 volt peak to peak, and for this V in we change this frequency F in, this frequency, and we will measure the output voltage. Once this is 1, 2, 3, 4, 5 and so on, let us say up to 12 readings, around 12 to 15 readings you can take here. Start from 50 Hz. Let us start with 50 Hz, then 100 Hz, then 200 Hz, then 1 kilohertz, then 2 kilohertz, then 10 kilohertz, then 20 kilohertz, up to let us say 100 kilohertz. So take these readings for different frequencies and measure the output at this side. So let us say this output is 0.3 volt, 0.5 volt, 0.6 volt, 0.10 volt, 0.15 volt, and so on. Measure this output voltage. And now take in the next column, calculate the magnitude of output upon input voltage. So here, calculate this output voltage upon this 0.5, that is input voltage is fixed, 0.3 upon 0.5, 0.5 upon 0.5, 0.6 upon 0.5, 0.10 upon, and so on. So you calculate this magnitude of this output voltage. Later on, you calculate this magnitude in terms of the decibels. So what is the formula? 20 log 10 magnitude of V naught upon V. You calculate this. This is in dB. So this value will be in decibels. So the same gain. This is the gain without decibels ratio, and this gain may be in decibels, dB. So calculate this value in dB. Once you get this table up, connect this circuit properly, connect the function generator at the input and one channel of the CRO at the input, connect the another channel of the CRO at the output, fix the input value 0.5 volt peak to peak at the input and vary the frequency, and measure the output on the CRO. So you continuously check this output and prepare this table. Once you got this table and calculation, then you may plot the graph between this gain versus this frequency. This gain versus frequency, either you can use the gain in ratio or you can use the gain in dB, both. So maybe plotted between these two. So how this plot will look like, I will tell you, I will show you here the characteristics of this amplifier after getting these readings, after calculation of this table. Here, take the vertical axis as this gain, V naught upon V in. This is called as gain. This gain either this column or this gain may be in dB. If you take in dB, there will be a change in dB here, or you will take the ratio, there will be a maximum value of ratio. And in the horizontal axis, you take this frequency, F in, input frequency. This frequency will start from 0 Hz and it will go to up to 1 megahertz. And make a certain scale on this frequency and make this maximum value. So this graph will be something like this. You will plot this graph, you will get graph like this. So this maximum value you will get here. This is called as mid-band gain. This is called as A max. Maximum gain you will get here. And if this is in ratio, then multiply by 0.707 times A max. This will be here. And sketch this horizontal line with respect to 0.707. You will get the two frequencies here. This is one frequency, this is another frequency. This is FL and this is FH. So this, within this frequency range, this 0.707 times A max is called as the bandwidth. So this is called as a particular bandwidth. So this is called as frequency response. That means within this particular bandwidth, we will get this flat response of the RC coupled amplifier that we have to show. What is the purpose of the practical? To verify the bandwidth of the RC coupled amplifier, to see whether in a particular bandwidth we will get the flat response or not. So this flat response we will obtain by plotting this within these two frequencies. Also, from the same you will get the lower cutoff frequency and higher cutoff frequency. So this flat response can be obtained within this particular practical RC coupled amplifier. So once you get this bandwidth, you will get the bandwidth as well as you will get the gain of the amplifier. What is the maximum gain of the amplifier? And one more thing, if you are not taking this gain, is this one. You can plot this graph also on a semi-log paper. But while plotting on the semi-log, you consider this gain in decibels. So you have to take this gain maybe in decibels. So gain A in dB. So you can take this in dB. So you will get this maximum A in dB, A max in decibels. You will get this particular. And now in place of 0.707, you have to less 3 dB with this maximum value. So this is minus 3 dB less of this A max. So 3 dB less, or you can say this is 3 dB less, 3 dB minimum. So in same graph you will get here in terms of the decibel. So either you can take the decibel in the vertical axis, or you can take this ratio without any unit. Without unit, if you are considering this, you have to multiply here 0.707 times A max, and if you take in decibel, you have to take a minimum of this A max, 3 dB minimum of this A max. So you will get the same thing. And same graph you may obtain either on semi-log paper or on a simple paper. On both paper you can plot it. So this is called as frequency response of the RC coupled amplifier. Are you getting my point? Are you understand this practical also? This is theoretical part and practical part also. But the purpose of the practical is to understand this response. And same thing you have to write in the theory. What is the purpose of the RC coupled amplifier? The main purpose of the RC, from this practical you can write down the conclusion also. From the same experiment we find that RC coupled amplifier using the